On this large construction site, the foundations have already been completed and the crews are now fully focused on the steel fixing of vertical elements. For a project of this scale, huge amounts of steel must constantly be moved and distributed across the site. That was the job of the two-man sub-crew we observed and interviewed. Their task was straightforward but essential. All the steel bars are first delivered and stockpiled in one location. From there, they need to be transported to different work zones. The two workers we interviewed were in charge of preparing and securing the bundles so that a crane could safely lift and move them to the other section of the site. They cleared the area, fastened the loads, coordinated with the crane operator, and ensured that the steel was set down where the fixing teams needed it. The logistical role is critical to keeping the entire steel fixing operation running, but it also creates sources of inefficiency. With only two workers handling heavy bundles, the process is slow and physically demanding. Their progress depends heavily on crane availability, which often leads to waiting times. And because all the steel is stockpiled in one place, every transfer requires significant extra movement before the bars can even be fixed in one place. Steel fixing productivity is typically measured in man-hours per ton of steel. Reported rates vary widely from about 8 to 30 hours per ton, depending on bar size, structural complexity, vertical versus horizontal work, and site conditions. This variability is explained in part by logistics. If steel is not delivered close to where it will be used, or if crews rely too much on crane coordination, overall productivity falls. In summary, although this two-man team may look small, their efficiency has a major influence on the larger workforce. The faster and smoother the steel is distributed, the more productive the fixing crew across the site can be.